Hey, welcome to the third video in our series on properties of logarithms for section 6.5. In this video, we're going to talk about the exponent rule. In the past video, we just talked about the product rule, and we worked on an example where we evaluated log 2 of 2 to the 4th times 3. And what was interesting about that is the product rule allowed us to split this so that it looked like log 2 of 2 to the 4th plus log 2 of 3. So if we knew what log 2 of 3 was, we would have the exact answer that we want because we had no problem evaluating log 2 of 2 to the 4th. Remember, that was just 4. So one thing that people hate doing is finding explicit, like good representations for logarithms. It can be tough to do. And in the past, before like calculators were widely available, it was very computationally intensive. So it was nice to work with just a few key examples. So for instance, computing log 2 of 2 to the 4th, we could actually really compute any number log 2 to the k times 3 if we just knew what log 2 of 3 was. So it wouldn't be too much trouble. We just have to add on this extra value. And in this video, we'll see that it actually gets better than that. The exponent rule will let us evaluate anything that looks like log 2 of 2 to the k times 3 to the, let's say, m, so some other power. We'll be able to evaluate something like this, where the only knowledge we need to know is what log 2 of 3 is. So if we know what log 2 of 3 is, then we don't have to worry about what log 2 of 9 is, log 2 of 27, log 2 of 81, log 2 of 1/3. They won't matter so long as we know what log 2 of 3 is. And we'll see what happens in this exponent rule. All right, so we'll start with an example and look at log base 2 of 3 to the 4th. And we're going to use a similar idea that we used in the product rule, where we're going to write 3 as being equal to 2 to the k. So we'll let k be that solution to 3. And we also know that k is going to have to be log 2 of 3. And we can already see that this is going to connect to what's above. We just had a log 2 of 3 show up. So we'll write log 2 of 3 to the 4th is the same as log 2. Now we're going to plug in that 2 to the k. 2 to the k to the 4th. Remember, 2 to the k is just 3. We're just using it as a little handle to derive this exponent rule. We'll simplify our exponent. And next, we actually get to use our favorite rule, the inverse rule. So the log 2 and the 2 cancel out. It's our inverse rule. And we're left with just a 4k. And what's even better is we know what this k is. It's log 2 of 3. So this is the same as 4 log 2 of 3. And so there we go. We have log 2 of 3 to the 4th is the same as just 4 times log 2 of 3. So if we knew what log 2 of 3 is, we could evaluate log 2 of 3 to the 4th by just multiplying log 2 of 3 by 4. And this gives us the exponent rule in general, where it's log base A of this time a number, so b to the r is the same as r log a of b. So whereas before, when we had the inverse rule, it let us just bring down that single exponent, and the log a and the base a would cancel out with each other. Now we're still left with a log a b, but we pulled that exponent down. So for example, to evaluate log base 2 of 2 to the 5th times 3 to the 7th, this is just first applying the product rule. We split it as we get 2 to the 5th plus log 2 of 3 to the 7th. The first one we know by our inverse rule breaks down to just being 5. And the second part by our new exponent rule becomes 7 times log 2 of 3. So we can evaluate this crazy big number, which is 32 times 27 times 81, because this is 3 cubed, this is 3 to the 4th. So together they multiply to 3 to the 7th. We can figure out exactly what it is, so long as we can figure out what log 2 of 3 is. So yeah, that's the exponent rule, another very nice rule in the story of logarithms.